folks, welcome back. Let's take a look at two fractions that we're being asked to subtract, but I want us to make sure we're able to handle the fact that we have to subtract this entire numerator. All right, and so we're lucky in that these fractions do have common denominators, all right, but when subtracting rational expressions, right, fractions, note that the entire numerator of the second fraction, not just the first term, must be subtracted. So what that means is not only do I need to subtract the x squared, I need to distribute the subtraction to the negative 4x and then this subtraction to the negative 5. So ultimately I'm going to have negative x squared plus 4x plus 5, but I'll write that out in just a moment, all right? So essentially the sign of each term in the numerator being subtracted will change when the parentheses are removed. And you're like, what are you talking about with parentheses? Imagine there are parentheses protecting these trinomials. Ooh, that is a terrible parentheses. All right, so when it comes to fractions, your first game plan is to make sure you've got common denominators, and I do, right? The first few examples, the denominators are already common, so you're in good shape there. So I'm gonna keep this common denominator of x squared plus 7x plus 12, and then I'll just combine, oops, I forgot the squared term, excuse me, combine these numerators. Right? And so we want to just make sure we're distributing this subtraction not just to the x squared, but to the negative 4x and the negative 5 as well, right? So the entire numerator of the second term needs to be subtracted, not just the first term. So I get too often where students will only hit minus x squared, and then they'll write minus 4x minus 5. Actually, let me write this out. This is what I'm trying to say. So I get this all the time where students, and I get where you're coming from, x squared will write, x squared, students will write that and they'll do minus x squared minus 4x minus 5. And so essentially what they do is they subtract this first term, but they don't wind up distributing that subtraction to the negative 4x and then the negative 5. This should actually be plus 4x and plus 5. So those signs should change on every term of the numerator in that second fraction. And then it's a matter of collecting like terms. So let's see what we've got. All right, so I have an x squared here and a minus x squared here. I have a linear term of minus 2x and another linear term of plus 4x. I have constants of 3 and 5, both are positive, so let's combine these together. So as we start to play this out, the squared terms will cancel. Negative 2x plus 4x is positive 2x. 3 plus 5 is 8, and I've got x squared plus 7x plus 12. And then we need to factor this if possible, right? And so this if I look, I can at least see that I have a GCF on the numerator, so I'm going to factor out the 2, and I'm going to get left with x plus 4. And then I want to think of numbers that multiply to 12, positive 12, and add to positive 7. And I can break that into x plus 4, x plus 3, right? 4 times 3 is 12, but 4 plus 3 is 7. And then you can see there's a factor in common. I've got x plus 4 in the numerator and x plus 4 in the denominator. And you can cancel binomial to binomial. These are the same term, so I'm going to divide that out. And ultimately, I have 2 over x plus 3. All right? So there's example 4. Now, when we move on to the next examples, things are going to get wonkier. And I say wonkier because examples 1 through 4, you've had common denominators each time. So for the rest of this section, the denominators are not common. So we're going to have to first find common denominators and then do all the shenanigans we've been talking about in here. All right? Thanks so much. Bye.